Tick-tock, tick-tock, the end is consistently drawing closer, and there may be no district to stow away any further. What we dreaded has, at long last, occurred, leaving consequences that are making our existence deteriorate before our eyes. The shimmering purple giant star, Betelgeuse, has now detonated. The furiously anticipated endless impact has fanned out, attacking the force of our environment and announcing the appearance of a staggering first light for humankind. But what proof did experts uncover that led them to reveal this confirmation? How incredible could Betelgeuse shine in the night sky if it detonates? Should this effect cause the obliteration of our planet? Could we pass nearby with it? In this video, we explore the fascinating details of the harmful program Pulverize, which has now detonated, and examine the unsettling events that followed. For quite some time, Betelgeuse has preserved its superb significance in the night sky, mesmerizing spectators from Earth. Perhaps the purple giant star works its magic with its bewildering appearance. Betelgeuse is a member of an exclusive class of stars that shine brightly enough for us to see, located in the Orion constellation. This purple supergiant is the 10th most brilliant star in the night sky, allowing everyone to admire its reddish-orange glow. One captivating fact about Betelgeuse is that it is one of the 3 stars that make up the winter triangle asterism, which also forms the centerpiece of the winter hexagon. From January to mid-September, Betelgeuse can be seen moving east after sunset, and by mid-March, it is visible from almost every inhabited region on Earth except Antarctica. On a typical night, when daylight fades and darkness sets in, Betelgeuse is easily recognizable among the stars that adorn the sky. Despite its brilliance, Betelgeuse is shrouded in mystery. Researchers have long been intrigued by how its brightness varies, a characteristic that has remained consistent over time. This peculiarity has drawn the attention of scientists and led them to investigate its nature further. They eventually discovered that the purple giant's changing brightness is due to its massive size. Betelgeuse is not an ordinary star. Its size surpasses that of its stellar peers. For instance, if Betelgeuse were to replace our Sun, it would expand to the asteroid belt. It has a mass 20 times greater than the Sun. While this fact is impressive, it pales in comparison to its other astonishing features. Further studies revealed that Betelgeuse is a fiery supergiant star, estimated to be 8 to 10 million years old. This discovery surprised astronomers, as they had initially expected the star to be much older due to its extraordinary characteristics. In contrast to our Sun, which has an average age of 4.6 billion years, Betelgeuse is relatively young. However, despite its youth, the red supergiant compensates with its immense size and luminosity. Researchers found that supergiant stars like Betelgeuse burn through their nuclear fuel at an accelerated rate, leading to a spectacular explosion. These stars grow quickly and, in many cases, live short but extraordinary lives. From the little we have been able to piece together, it appears that the explosive transformation of Betelgeuse may have occurred sooner than humanity expected. Betelgeuse and other dying stars began their journey long before anyone alive today was born. To understand how investigators concluded that the red giant star had detonated, we need to start at the beginning, the very beginning of this celestial story. This captivating tale began as far back as the 2nd century BC when Chinese astronomers made an accidental discovery. They observed a peculiar radiant star in the night sky, which they named Betelgeuse. The description of this star, by a yellow tone, staying away from a couple of scenes to the accompanying remarkable genuine moment, leads us to the focal point of the 2nd century, when Greek-Roman stargazer Timmy was captivated with the aid of the overpowering appearances of Betelgeuse and portrayed it as orangish or rosy, which stays significant to this day. Likewise, ancient observers in the Middle East had noticed a similar view at this union. The question at the front of everyone's mind is how tones were named or owned in the past. We shouldn't forget that there is a real possibility that Betelgeuse underwent an evolution or exchange across time. Furthermore, Chinese astronomers may have observed the fading yellow glow, which endured for a significant period as years turned into decades and centuries. It is plausible that the massive star eventually transitioned into the red supergiant stage we see today. Another essential perspective about Betelgeuse is that it is a variable star, as it appears to undergo cyclic changes. For example, in December 2011, researchers discovered with astonishment that Betelgeuse's brightness had diminished significantly. Scientists were perplexed, as their observations could not initially explain the phenomenon. Across the globe, people familiar with observing this star noticed its brightness had dipped alarmingly, raising many questions. This peculiar event led to speculation that something extraordinary had occurred for the star within the Orion constellation. However, by mid-2020, the star had returned to its standard brightness, mirroring its former prominence. It is fascinating to note that this change was gradual, as astronomers observed Betelgeuse's brightness steadily recovering over several months. Some researchers proposed hypotheses to explain this unusual event. According to one theory, part of the star's life cycle had synchronized, causing the dramatic drop in brightness. When scientists sought the assistance of the Hubble Space Telescope to analyze the event, the telescope provided astonishing observations. It appeared that Betelgeuse had ejected a massive amount of material, leading to its dimming. The red supergiant star could eventually approach the supernova stage, an extraordinary event that would undoubtedly make history. A supernova is the spectacular and explosive end of a massive star. When this process begins, the core collapses, potentially forming a neutron star, a black hole, or disintegrating into a cloud of debris. If Betelgeuse were to explode today, the energy released would be immense, with potentially devastating effects on the surrounding space. The mere thought of this possibility is enough to alarm anyone. Imagine the vast amount of radiation, from gamma rays, X-rays, and other emissions, being released in a single event. If this radiation were to reach Earth's atmosphere, it could lead to global health crises. Scientists have determined that such radiation could damage DNA, disrupt cellular structures, and cause widespread mutations or cancer. Thankfully, Earth's atmosphere is well equipped to shield us from such catastrophic radiation. Despite these assurances, the potential for Betelgeuse to go supernova in the near future has kept space scientists highly alert. Recent studies indicate that the star is still far from its impending supernova event, though some evidence suggests that preliminary activity may already be underway. A groundbreaking paper by Hideyuki Seo and colleagues at Tohoku University in Japan revealed that Betelgeuse might have already experienced an initial supernova event before its effects reached us. This revelation is both astonishing and unsettling. We may start observing the aftermath of this cosmic event within the next decade or so. As astronomers grapple with this knowledge, they are reminded that the last recorded supernova in our galaxy occurred in the 1600s, Kepler supernova, a striking reminder of the immense power and unpredictability of the cosmos. The recent revelations about Betelgeuse have left astronomers and enthusiasts pondering over the mysteries of the cosmos. The delicate balance of celestial events, from the cyclic changes in brightness to the star's eventual fate, highlights the complexity of the universe. If Betelgeuse does reach its supernova stage, it will provide an unprecedented opportunity for scientists to study the life cycle of a massive star in real time. However, such an event would not only mark the end of a colossal star but could also serve as a new beginning, contributing to the birth of new stars and planetary systems from the debris. This process, known as stellar recycling, is a fundamental aspect of cosmic evolution. In essence, the remnants of Betelgeuse could one day become part of a new star, a new planet, or even the building blocks of life elsewhere in the universe. While the timeline for Betelgeuse's supernova remains uncertain, researchers continue to monitor it closely. Advanced telescopes like Hubble and the James Webb Space Telescope play a critical role in observing such celestial phenomena. These tools enable scientists to gather valuable data, analyze patterns, and predict the star's behavior with increasing accuracy. Despite the alarming possibilities, there is also a sense of excitement. Witnessing a supernova within our galaxy would be a once-in-a-lifetime event, offering unparalleled insights into stellar physics. It would allow humanity to observe firsthand the powerful forces that have shaped our universe for billions of years. As we await the next chapter in Betelgeuse's story, it serves as a reminder of our connection to the stars. After all, the very elements that make up our bodies, carbon, oxygen, iron, were forged in the hearts of stars like Betelgeuse before they exploded and scattered their material across space. In the end, Bug Juice's journey reflects the profound cycle of creation, destruction, and renewal that defines the cosmos. Whether its supernova occurs within our lifetime or centuries from now, it will undoubtedly leave an indelible mark on both the universe and our understanding of it.